Okay? Work is done by a force defined as the product of that force times, okay, the parallel distance over which it acts. Okay? So work is given by the equation force times displacement. Okay? The unit of work is Newton meter kasi si force is in newtons tapos yung displacement natin is in meters, or in other units, work is also in terms of joule. Okay? 1 joule is equals to 1 Newton meter. Work is scalar. Okay? Mamaya, madedefine natin kung bakit scalar ba ang work. So, meron din tayong isa pang equation of work which is FD cosine theta. Okay? So, paano na-derive tong equation ng work na FD cosine theta? So, for example, we have a force, we have an applied force inclined at a specific angle with relevance or with respect to x-axis. So, tong force natin to, since inclined siya sa x-axis, meron po siyang component forces. So, yung component forces niya, Fy and Fx. Okay? So, define natin ang work as parallel or force parallel over the displacement. If the object displaces towards this direction, which force is parallel to its displacement. Okay? The force parallel to its displacement is the x. Okay? The x component. X component, Fx is equals to F cosine theta. Okay? So, pwede natin siyang i-substitute dito sa work is equals to Fd. Okay? Gawin lang natin tong Fx. So, it is also equal to Fd cosine theta. So, this is another example or another equation that we can use in computing work kapag inclined yung ating force, applied force. Okay? So, work is force times distance, but may kailangan tayong consider sa work, force in direction of motion is what matters. Okay? So, yung direction ng force and as well as the motion is what matters. Why? Bakit nagmamatter yung force and saka yung direction ng motion? Kasi meron tayong iba't ibang values. Okay? May iba't ibang tayong values ng work. Ang work, pwede po siyang positive, pwedeng negative, pwede rin po tayong magkaroon ng zero work or walang work done. So, kailan po yun nangyayari? Okay. Work is positive. Okay. Work is positive when the force and displacement are in the same direction. Okay. So, also, we have a positive work kapag, okay, kapag parallel yung force kay displacement. Okay? So, this is the displacement, this is the force. So, hindi nyo ma-imagine, so i-apply natin siya sa situation. Kunwari, meron tayong body. Kunwari, meron tayong body on a horizontal plane or on horizontal surface. Tapos, nag-apply daw tayo ng force. Yan, nag-apply daw tayo ng force. Nag-apply daw tayo ng force, horizontal force, to our body. Okay? And the block moves in a forward path. So, in this kind of situation, since parallel yung ating forces and displacement, and they are in the same direction, we have a positive work. Okay? Also, kapag ang angle, kahit kunwari hindi siya parallel, paano yung, what if your force is inclined at a specific angle? Okay, since kukunin mo pa rin naman yung x and y components niyan, so yung x component mo ay magkakaroon ng congruency with your displacement. Okay? So this happens, kailan nagpa-parallel yung x component? This happens kapag ang angle mo ay less than 90 degrees. Okay? So kapag less than 90 degrees yung angle, also kapag parallel and the same direction yung force vector mo, kay displacement quantity mo, your work would be positive. Okay? Next, we have zero work. Okay? Kailan nagkakaroon ng zero, or kailan nag-equate ang work sa zero? Kapag ang force and displacement mo are perpendicular with one another or to each other. Or whether, when the value of your force and displacement is equals to zero. Okay? So, kapag wala kang force na in-apply, walang pagbabago sa motion, so yung work mo would be also equal to zero. Okay? So, ano yung example ng zero work? Okay? Katulad to nung waiter kanina. Okay? When we hold an object and walk, okay? The force acts downward direction, whereas the displacement acts in the forward direction. In this situation, okay, katulad ng waiter kanina, may hawak na tray, perpendicular yung, what do you call this? Perpendicular yung relationship between forces and the displacement. Okay, so we have zero work. Okay, pwede din natin siya i-apply mathematically using the equation f d cosine theta. Okay, so what if our object or the relationship between the force and the displacement has 90 degrees between them? Okay, kung i-apply natin yan, f d cosine 90. Okay, cosine 90 is equals to 0. Dito naman, cosine less than 90, lahat yan positive. Okay? Mag-move on naman tayo dito sa pangatlo, negative work. Okay? Negative work is performed if the displacement is opposite the direction of the applied force. So, katulad lang din siya nito, pero kahit parallel siya, yung direction ni force tsaka ni displacement is opposite. So, kailan to nangyayari? When the gravity, okay, on the rocket going perpendicular upwards. Also, kunwari may ball ka, okay, so yung ball is moving towards this direction, tapos may nakasulubong siyang isa pang ball, yan, napapunta dito, okay, so yung displacement niya papunta sa kanan, may nagtulak sa kanya na force papunta ka sa kaliwa. So most probably, the work done between these two balls would be negative. Okay? So as well as if we have angle of inclinations, so yung cosine greater than 90, okay, cosine greater than 90 is always negative. Okay? So, any questions? So, mahalaga po to na malaman natin kung kailan magpa-positive or magne-negative yung work para at least madali natin i-solve yung work done by a force. So, paano ba tayo mag-compute? But first, let us parang rely with this mga graphs. Okay, itong mga graphs na to, it is just the representation of the work done by a constant force. So, pag constant yung force natin, ganito yung itsura ng graph ng work natin if we are plotting it on a force position or, yes, a force position graph. Then next, kapag ka non-constant yung force, ganito yung itsura ng graph ni work. And then kapag continuously varying force natin, so ganito, as well as this one, continuously varying force. So when the force is not constant, yung area under the force distance curve or a force position curve is the work. Okay, this illustration simply tells us, okay, that as the force changes, as the distance changes, pwede natin i-compute using calculus, pwede natin siyang i-integrate, pwede natin siyang i-differentiate. Oh, okay. Kunin natin yung differential equivalent, okay, nung area under the curve. But, wag po kayo matakot, hindi ko naman sasamahan ng calculus po kasi baka lalong hindi nyo maintindihan yung concepts. Ang mahalaga naman kasi dito yung concepts rather than the computations. Yung computations, kaya nyo kasi siyang gawa ng, gaya nyo siyang i-manipulate, okay? So, yung concepts kasi, mahirap i-manipulate ang concepts. So the average force times distance gives the work. This is the same as the area under the curve. Okay? So, work and dot product. Okay, dito may explain natin. Okay, in this part may explain natin kung bakit scalar si work. Okay? So, but first, let us define that product. Okay, that product is the projection of one vector to another. For example, we have here vector A, okay, and we have vector B. So, ano ang relationship or ano yung effect ni vector A kay vector B? And ano yung effect ni vector B kay vector A? Okay? In that matter, kapag kukunin mo yung effect of one vector to another or the projection of one vector to another, we apply dot product. Okay? On our previous discussion kay vector, ang ina-apply lang natin is always vector addition. Okay? Yung vector addition using Pythagorean theorem as well as Sohcahtoa para makuha natin yung magnitude and direction. Dito, kay dot product, kukunin natin yung effect ng one vector to another. Okay? So, A dot B. Okay? So, ganito yung ganito sumulat ng dot product. Ano yung dot product between A and vector B? So, it is equals to the magnitude of A, absolute value, multiplied by the magnitude of B, absolute value. May naguhugas ng pinggan. Okay? So, multiply by cosine theta. Okay? So, ito yung equation kapag kinukuha natin yung dot product ng two vectors. Okay? Based from its definition, product, it means we are multiplying two vectors. Okay? So, ano yung relationship ni dot product kay work? Okay? Ano ba ang formula natin ng work? Work is equal to force times distance. Force is a vector quantity. Displacement is a vector quantity. So, itong dalawang to, kailangan nating i-multiply. Okay? Para makuha natin si work. Okay? So, kailangan i-apply natin yung dot product. That product is also called as scalar product. Bakit po? Kasi ang output ng or ang product ng dalawang vectors na i-multiply natin ay magiging scalar quantity. That's why work, kahit na vector si force, displacement ay vector din, work is considered as scalar quantity. Kasi, in-apply natin yung dot product. So, it would give us the equation work is equals to F times D cosine theta. So, based from this expression, work is equals to FD cosine theta. So, ito din ay isang explanation kung bakit ito yung ginagamit na equation for work. dahil po kay dot product. Okay? Any questions, mga kapatid? Clarifications. So meaning, since scalar quantity si work, ang nagmamatter lang talaga sa kanya ay magnitude. So hindi na natin kailangan hanapin yung direction ng ating force. Okay? Or yung direction ng ating work. Kasi magnitude lang ang kailangan natin. Ang mahalaga lang, alam mo, kung kailan magpa-positive or kung kailan magne-negative ang work done by an object. Okay? So, since we are talking about work and that product, how do we calculate work? Okay, work is calculated by this equation, FD, or work is equals to FD cosine theta. What if, dito kasi sa equation na to, isang force lang yung present. What if we have two or more forces? Anong gagawin natin para makalculate natin yung work? So, pwedeng para makalculate natin yung net work, hindi to hindi to TM, globe, or sun. Ang natin dito, total work done by the forces. So, para makalculate natin yung net work, kailangan kunin muna natin yung net force multiply by the displacement. So, this applies also kay cosine equation. Okay? Kailangan muna natin kunin yung net work. Okay? Net force rather. Okay? So, yan. Try natin dito sa mga given diagrams natin. So, we have diagram A. Meron daw tayong 15 kilogram box. Nag-apply force daw tayo ng 100 newtons. Okay? The object has a horizontal distance of 5 meters with a constant speed. Okay? What is the work done by the force to the object? Ano muna natin? Since positive yung displacement, most probably it is going to this direction on the positive x-axis. So, i-diagram lang natin siya, FBD. So, this is our 100 newtons, FA. Okay? So, what is the work done? Use the equation F times D. Since cosine 0, hindi naman siya naka-inclined. Cosine 0 is 1. So, cancel na natin yung cosine. So, F is equals to 100. The displacement would be 5. So, the work done here is 500 joules. Nakuha po ba, mga kapatid? Yan. What if may friction na tayo? Kunwari, hindi frictionless yung surface. Ano yung mangyayari sa equation natin? Anyone? Anong mangyayari dun sa equation natin? So, magkakaroon na tayo ng effect from the friction. Okay? So, ang kukunin na dapat natin is F net. Okay? So, hanapin muna natin si F net. F net is equal to, since nasa x-axis lang yung force natin, so yung mga forces along x-axis, FA, okay, i-minus ko na si FK. Okay? Kasi opposite in direction. So, si FK, or si kinetic friction, equal yan sa mu K times Fn. Ang gagamitin ko dito, Fn is equals to positive mg. Gagamitin kong positive yung Fn dito kasi pataas po siya. Okay? So, wag pong malilito ha. Ang gagamitin kong mg ay positive kasi pataas dito si Fn. Okay? So, Fa minus mu K. So, substitute ko na mg. Okay? So, substitute natin yung mga given, 100 minus, yung mu K natin, for example, 0.25. 0.25 times the mass, which is 15, times acceleration due to gravity, 9.81. Okay, what would be the value of F net? 100 minus 0.25 times 15 times 9.81. So the value of F net would be 63.2125 newtons. Tama po ba? Pareho po ba tayo na compute? So since meron na tayong F net, so pwede na natin siyang substitute dito. 63.2125 times the distance, or the displacement rather, is 5. So net work is equal to 316.0625 joules. Okay? So, nakuha po ba? Basta pagkakunwari 2 or more forces yung mag-a-act, kukunin mo muna yung net force, saka mo kukunin yung net worth. So, pwedeng, meron pa isa pang way sa pag-calculate ng net work. Net work is also equal to the work done by the applied force minus the work done by the friction. Minus ko na siya ha, kasi opposite in direction. Okay? It is also equal to this equation. Okay? Kasi di ba net work is the summation of all works done by the forces. Okay? So, individual, kunin natin si FA, work done by the applied force. So, ito yon. Na-compute na natin siya. 500 joules. Tapos, work done by the friction. Okay? So, work done by the friction, 0.25 times 15 mass times 9.81, okay, times 5, which is a displacement. So 183.9375. Okay? So, negative po yan kasi negative si friction. As well as, pag kinosine 180 natin yan, cosine 180 is negative 1. Okay? So, kaya negative din si friction. Nakukuha po ba, mga kapatid? So, i-minus lang natin to 500 minus 183.9375. So, we would be arriving at the same answer. Is equal to 316.0625 joules. Okay? Any question? Kapatid, clarifications? Yan. So, kung madadagdagan man yan, kunwari, magkakaroon ka ng tension force, normal force, weight, and spring force, kung ano man yung magkakaroon. So, idadagdag mo siya sa pag-compute mo ng network or individual work done by individual forces. Saka mo siya i-add. Okay? Next, we have here diagram B. Ayan, paano pag meron na tayong tension or force 100 Newton inclined 30 degrees, what would be the work done by the object? So, gamitin lang natin yung equation na work is equals to F d cosine theta. Okay? So, 100. Kasi, bakit cosine theta? Given the equation, and Fx is also parallel to the displacement of the object. So, Fd, 5 pa din. Cosine 30. So, 500 cosine 30 is equal to 433.0127 joules. Okay? Tanong po, mga kapatid sa pananampalataya. So, ganyan lang yan ha. Kunwari, andito naman yung force natin. Yan. So, ito 30. So, ano yung gagamitin nyo dyang angle? Very good. So, 180 minus 30. Kasi kailangan natin yung angle reference to x-axis. So, this is 180 yung isang buong straight line minus 30. So, 150 yung gagamitin mo. F 105 cosine 150. So, most probably, since greater than 90 yung angle natin, our work would be negative. Okay, 500 cosine 150 is negative 433.0127 joules. We move on to diagram C. Okay? So, meron daw tayong 15 kilogram with an upward force to lift, okay, yung 15 kilogram object to a height of 5 meters. Okay? At a constant speed. Since meron dito, hindi lang nasabi, meron diyang weight or FG equals sa mg. So most probably, the maximum or the minimum force for us to lift, okay, this 15 kilogram box would be also equals to mg. Okay, na equal sa 15 times 9.81. Okay, 15 times 9.81 ay equal sa 147.15 newtons. Okay, so itong upward force, minimum upward force na required para ma-lift natin yung 15 kg na object is 147.15. So, what is the work done by the object? So, what is the work done by the object? So, 147.15 multiplied by 5. So, yung work done is, very good, 735.75 joules. Very good. So, any questions? Clarifications? Okay, what if hindi pataas yung movement ng object natin? What if hindi siya nag-displace pataas? What if nag-displace siya papunta sa right? What would be the value of our work? Kung iaano natin siya, i-graph natin, this would be our force, applied force. Okay? Or Fn. Gawin na lang natin Fn para pareho na lang dito. Tapos nag-display siya papunta sa right. Good. So kapag nag-display siya papunta sa right, pero ang in-apply mo ay pataas, they create 90 degrees angle. So your work done would be equals to 0. As well as kung mag-display siya papunta sa right. Basta mag-create yung dalawang force at saka displacement ng 90 degrees, equivalent na agad din sa 0. Kapag naman pababa yung displacement ng object mo, okay, kapag pababa naman yung displacement ng object mo, pero yung paghigit mo sa kanya is pataas, ano yung value most probably of your work? Okay, very good, kapatid. So, magiging negative siya kasi opposite na yung direction ng applied force mo sa displacement ng object, as well as due to gravity. Okay? Very good. So, medyo nagagrasp natin yung concept. So, now let's move on with energy. Okay? Energy is the ability to do work. So, energy is the ability to do work, mga kapatid. Okay. Sa kinematics, meron tayong general type. Okay? Meron tayong general type of energy. And that is what we call mechanical energy. Okay. So, yung mechanical energy, meron yung dalawang classification. So, yung potential energy at saka kinetic energy. And what is the difference between potential energy and kinetic energy? Potential energy is the energy at rest, while kinetic energy is the energy in motion. tandaan niyo pa po ba kung ano yung equation na ginagamit natin for kinetic energy? So, yung kinetic energy is equals to 1/2 mv squared. How about potential energy? Sino po nakakatanda? Based from those two two equation, so makikita natin na si kinetic energy nagre-rely siya, okay, sa velocity at saka sa mass ng object mo. Okay? So pagbilis nung speed ng object, so nagkakaroon tayo ng value ng kinetic energy. While potential energy is first, specifically, gravitational potential energy is equals to mass times acceleration due to gravity times the height. Okay? So, dito naman, since potential energy is the energy at rest, so ano dito, kung ano yung stored energy mo at specific position sa Earth. Okay? So, meron pa tayong dalawang klase ng potential energy. Yung na-define natin kanina, mathematically, yung MGH, equivalent po siya siya po yung tinatawag nating gravitational potential energy. And what is it? So it is the potential energy due to the object's position. So kung nasang position po siya sa Earth, okay? So yung position niya, most probably ay at rest. Okay? Next, we have elastic potential energy. This energy occurs if an object is stretched or compressed. Okay, based from the term elastic, so ni-stretch natin, tsaka kinompress natin. Ang equation niya kakaiba kay gravitational potential energy. So yung sa elastic, equivalent siya sa 1/2 kx squared. Okay? This is derived from Hooke's law in his study on springs and such. Pero mas mag-focus tayo kay gravitational potential energy kasi this always occurs sa mga problems natin sa kinematics. Okay? So, we also have a law of conservation of mechanical energy. This law states that an energy can neither be created nor destroyed, but can only be transformed to one kind or another. So, dito, ini-state ng law na hindi po tayo pwedeng makagawa ng energy. Hindi rin natin pwedeng tanggalin yung energy or sirain yung energy. Yung energy natin, nako-convert lang po yan para yung PPT, okay? So, pwede mo siyang i-convert into one form or another. So, given the equation to prove this law in kinematics, okay? Kasi meron tayong law of conservation of energy sa electrical energy, magnetic energy, pero for mechanical energy sa kinematics or sa mechanics, so KE is equals to KE plus PE. Yung initial kinetic and potential energy is also equal to the sum of the potential energy final and the kinetic energy final. Okay? So, dito, may example tayo, tinuro natin yung ball. Okay, at what point tayo magkakaroon ng maximum potential energy and maximum kinetic energy? Okay, yung maximum potential energy is makukuha mo in the peak. Okay? So, in the peak of your projectile. Kunwari, nagkaroon tayo ng projectile. So, yung maximum potential energy, it is the highest value kapag nasa peak. Bakit po meron tayong highest value kapag nasa peak? Kasi ito yung may pinakamataas na height. Okay? Kasi di ba nag-rely yung height sa yung gravitational potential energy sa height. So, kung saan tayo mas may pinakamataas na height, doon tayo may pinakamataas na potential energy. And then, yung maximum kinetic energy natin, maano natin yan, ma-measure natin yan when the object is about to stop. Okay? So, kung kailan siya titigil. Okay? Or kung kailan mataas yung velocity niya. Okay, as the basketball player throws the ball into the air, so yung various energy conversions take place. So sa isang motion ng object natin, hindi lang all throughout, these diagrams prove na hindi lang all throughout dun sa motion ng object natin, magkakaroon tayo lang ng kinetic energy or potential energy. Hindi mo pwedeng ma-conclude na, ay ma'am, gumagalaw po yan. Kinetic energy lang po yung meron yan. Ay ma'am, nakatigil po yan. Potential energy lang po yung meron yan. Hindi, mga kapatid. So even though an object is moving, an object is about to move, or an object is about to stop, it has potential energy or it has kinetic energy. Kasi nga, yung energy, hindi po yan nawawala. Nagko-convert lang po yan. Nagta-transform lang po yan into one form to another. Initially, if an object is at rest, it has potential energy. And then kapag ka nag-apply ka ng force, magbabago yung state niya. Okay? Pag nagbago yung state niya, yung energy na meron yung object na yon, nagiging kinetic energy. Okay? The amount of kinetic energy transferred to an object is equal to its work done. So habang nagbabago yung kinetic energy mo, given delta KE, mako-compute mo din yung value ng work done by the object. Okay? So meaning, net work is also equal to KE final minus KE initial or not. Okay? Any question regarding this one? So, pwedeng dalawa yung ways mo ng pagkuha ng network. Pwedeng through forces and displacement or pwedeng through the energy perceived by the object. Okay? Which is given the equation delta K. Okay? So, please expect this. The solution for this problem, we have two problems here. Sa video lecture na i-upload ko po. So, alam na po kung kailan work ay zero, positive, or negative, or kailan mapaperceived, kailan nagbabago ang kinetic energy, potential energy, paano natin i-relate si work kay energy. So, that is the summary of our discussion for today. Any